During my current adventure trying to get a simulator to run at a reasonable speed, I considered spreading the calculations across multiple goroutines. This led me to wonder about how much overhead is involved in spawning goroutines, and what is the most efficient way to use them. If you search for answers to these questions, all you'll find is goroutines are really lightweight, so use them as much as you want. While I found that to be true, there are still choices on exactly how to use goroutines to get the maximum performance improvement. So I constructed more experiments. The work being done is simple integer math. The first two experiments follow a pretty typical usage pattern. Create a wait group, start a bunch of goroutines, and wait for them to finish. The first test creates a small number of goroutines and gives each one a lot of work to do, while the second test starts a large number of goroutines and gives each one a small amount of work to do. The third test follows a pattern that you'd often see in languages that only have heavyweight threads. It starts a small number of goroutines, then uses channels to communicate work to these goroutines. The results are pretty interesting. Doing 100 billion calculations in a single thread took my computer about 23 seconds. Since my computer has 16 CPU cores, the fastest speed for these calculations would be about 1.4 seconds if Go's multiprocessing were 100% efficient. The worst performance occurs when starting many goroutines and giving them each a small amount of work. At the scale I tested at, 2,560,000 goroutines were used, each doing 40,000 calculations. This took about 6.5 seconds. While very fast, it does demonstrate that overhead starts to creep in with a large number of goroutines. However, it's notable that such a large number of goroutines still performs really well. The fastest performance occurs when starting 64 goroutines and giving each of them 160 million calculations to do. This finishes in about 3 seconds, which is only twice as long as the theoretical best case. When pre-launching 64 goroutines and feeding them 40,000 calculations worth of work at a time over a channel, the result is a runtime slightly longer than 6 seconds, which is almost as slow as starting over 2 million goroutines. There's definitely some overhead in channel communication, but it's still impressive how well it performs. Overall, the advice to assume that goroutines are so cheap that you should just start them whenever you want without worrying about the cost seems to hold up. Of course, there is some overhead, but trying to optimize use by pre-starting the goroutines is only marginally faster than creating what many would consider an excessive number of goroutines. Additionally, the pattern of wait group start wait is far simpler code than the channel management required for pre-starting the goroutines.